The question we are solving now belongs to test series 2. It is of control system subject and in specific it belongs to signal flow graphs of the control system. There is a signal flow graph given which contains three forward paths. The first forward path is being drawn. It has branches of gains 2, 1 by s, 1 by s and 1. It has another branch which connects the nodes as shown. So that constitutes the path 2. There is a third path which connects the input and output nodes, which has branches of gains 1, 1 by s and 1. The signal flow graph has three loops, which has loop gains of minus 1 by s, minus 1 by s, and minus 2 by s. If R of s is input and C of s is output, we have to find the transfer function relating input and output. We know that this transfer function can be determined by Mason's gain formula, which is given as sigma pk delta k by delta, where pk is gain of forward path k and delta k is graph determinant without forward path k and delta is graph determinant. From the signal flow graph, p1 is equal to which is p1 is equal to the gain of the forward path 1, which is 2 multiplied by 1 by s multiplied by 1 multiplied by, sorry, this should be 1 by s multiplied by 1. So this is equal to 2 by s square, and p2 is equal to gain of the forward path 2, which is product of the terms 2, 1 by s and minus half, which is equal to minus 1 by s, and p3 equal to product of the gains 1, 1 by s and 1, which is equal to 1 by s. And L1 is loop gain 1, which is minus 1 by s, and L2 is loop gain 2, which is minus 1 by s, and L3 is loop gain 3, which is minus 2 by s. From the above, the graph determinant of forward path 1, that is delta 1, can be written as 1 minus L3, that is equal to 1 plus 2 by s, and delta 2 is equal to graph determinant without forward path 2, which is 1 minus L2 plus L3, which can be written as 1 plus 3 by s plus, sorry, 1 minus L2 plus L3 plus L2 L3, which can be written as 1 plus 3 by s plus 2 by s square. Similarly, delta 3 can be written as 1 minus L1 plus L2 plus L1 L2, which can be written as 1 plus 2 by s plus 1 by s square. And the graph determinant can be written as delta equal to 1 minus L1 plus L2 plus L3 plus L1 L2 plus L2 L3 plus L3 L1 minus L1 L2 L3, which on substitution becomes 1 plus 4 by s plus 5 by s square plus 2 by s cube. On substituting the quantities p1, p2, p3, delta 1, delta 2, delta 3 and delta in the equation A, we get P of s is equal to 2 by s square as a whole multiplied by s plus 2 by s minus 1 by s square minus 1 by s multiplied by s square plus 3s plus 2 divided by s square plus 1 by s multiplied by s square plus 2s plus 1 divided by s square as a whole divided by s cube plus 4s square plus 5s plus 2 divided by s cube, which on simplification becomes s plus 3 divided by s plus 1 whole square multiplied by s plus 2. So the correct option is